So let's look at how we can use these relationships formed by similar triangles with scale factors relating them and proportions in order to solve problems involving some missing pieces. So a lot of times the situation where we're using this is where we don't know a side length. So notice on this one, we have two similar triangles, and we don't know this side length and we don't know this side length, but we do know one of them down here. So that allows us to find what our scale factor is. That allows us to set up a proportion. We're going to look at a couple different ways of solving these problems to find what those missing pieces are. Now, one way you could do this doesn't actually use a proportion. It just uses a scale factor. So remember, to find a scale factor, we just need two corresponding sides, which we do have. We have 14 and we have 4. Those are corresponding sides, BC and BC, on the dilated shape and the original shape. And both of those are the long leg of a right triangle. So those are corresponding sides. They have the same relative position and relative role in that shape. So we could find our scale factor by dividing 14 by 4. And we get 3.5. So that's our scale factor. So we could use that scale factor and we could multiply 3 times 3.5 in order to find the short leg. So that would be, let's see, 3 times 3.5, you get 10.5. And then you could also take 5 times 3.5, which is 17.5. So those would be the other two missing sides, AB on the bigger shape and AC on the bigger shape. So that is one way to do it, and that's fine. It works perfectly fine. It's sound mathematical reasoning and everything. It gives you the exact correct answer. But it's always good to have more than one way to solve a problem. So if you kind of get in a tough problem where you're having a hard time deciding, usually it's a hard time deciding what numbers to multiply together, what numbers to divide, and stuff like that. And a proportion actually really helps you organize that thinking. What numbers get multiplied, what numbers get divided to give you the correct missing side length. So I also wanted to show how you would use a proportion in order to solve this problem. And I really encourage you, when you're doing the practice problems below, to try doing it both ways. Identify the scale factor and use that to multiply or divide the known side length to get the missing side lengths, but also solving a proportion, writing and solving a proportion. So when I say proportion, I'm going to actually go back up here to the top. A proportion is just one of these equations we have. So a proportion is just an equation relating, and this is just, there's proportions all over this. A proportion is just an equation relating two equal ratios. So this is a proportion, this is a proportion. Down here where we're writing these are proportions, where whenever you have two ratios set equal to each other, we just call that a proportion. And proportions have some special characteristics. And so one of the things that I wanted to show you, and it's this characteristic that allows you to write a proportion and then solve it to find a missing piece. What I wanted to show you is, notice when we write a proportion, so if we look at this one, notice 10 times 1, which is 10, is also equal to 5 times 2, which is also 10. And in the proportion below it, that same relationship ends up being true. Notice if we multiply those two numbers that are diagonal to each other, they call those cross products, they're equal. So in this case, 4 times 2 is equal to 8 times 1. And they call those cross products. So 8 times 1 is equal to 2 times 4. And in the one above it, we had 10 times 1 is equal to 5 times 2. So what we say from this relationship that we get is that cross products, those are just the products of numbers that are across from each other, that are diagonal to each other in that proportion. Cross products are always equal in a proportion. And this is what allows us to write a proportion with a missing piece. and then algebraically solve for what that missing piece is. So cross products are always equal in a proportion. If those cross products aren't equal, you don't have a true proportion. Okay, so let's see how we can use this in order to find a missing piece. And since we already know what these missing pieces are, we can check our work to see if we get the same result, which we will. So let's try this using cross products. So this time I'm going to write a proportion. And so on this one, I'm going to start with what we did before. 14/4 is a ratio relating corresponding parts. And we know that that ratio, when we're comparing two similar shapes, should be equal to the ratio of, let's say, AC in the larger triangle, that's the hypotenuse, to AC on the smaller triangle, which we know the length of, which is 5. So we know that this is a proportion. It is an equation relating two equal ratios. So the ratio of the hypotenuses should be equal to the ratios of the long legs of these two similar triangles. And so we know that the cross products are equal since this is a true proportion. So we know that that product should be equal to that product. And remember this AC, that was one of our question marks, right? AC. So we know that 14 times 5 should be equal to 4 times whatever AC is. And the long ones, the little apostrophes. And so now what we actually have is an algebraic expression with one missing piece. Now we know that 14 times 5 is 70. So 70 equals 4 times AC. I'm just going to actually use a question mark for our unknown there. You could also use like X because we use that a lot for the missing piece in an algebraic expression. And in order to solve this, we could just divide both sides by 4. So we really just have an algebraic expression. Now, if you divide both sides by 4, those cancel out. And if we do 70 divided by 4, we get 17.5. And so notice we get the same thing that we got up here. That's a good thing. Just two different valid ways of solving the same problem. Now you might recognize the procedure that we did. It kind of has a shortened way of describing what this procedure is, and it's called cross multiply and divide that we just did. So what this is called is cross multiply and divide. It's just kind of an easy way to remember because it kind of rolls off the tongue, cross multiply and divide. Cross multiply means multiply the two numbers that you have that are across from each other. So in this case, that would be 14 times 5. So those two values are across from each other. Cross product of those is 70. The divide part is dividing by the number that's across from the unknown. So cross multiply the numbers that are across from each other. Divide by the number that's across from your unknown. So 4 in this cross product, 4 times AC, 4 is across from the unknown in that cross product. So cross multiply and divide. And when you get good at these, once you set up the proportion, you don't have to write out all of these algebraic steps for solving for the variable. You'll get good at just multiplying the numbers that are across from each other and dividing by the number that's across from the unknown. So try using this strategy in order to find the other missing sides. So AB on the large triangle, and then check your work. So I'll go over how to do that so you can check your work. But try doing it first yourself, and you should get the same answer as you did previously. You should get 10.5 because that's what we got just using the scale factor. Try finding that using a proportion and cross multiplying and dividing. And then check your work. So to solve this one using a proportion, you could start out using the same ratio. So we have those two sides given in the original problem. So 14/4 that ratio should be equal to our unknown, which is going to be AB, over 3. So the ratio of corresponding sides. So if we cross multiply, our cross products are going to be 3 times 14, and that should be equal to 4 times AB. And again, you can use AB to use the actual side on the triangle. You can also just use any variable. You could just use X or a question mark or something for that unknown. And then if we cross multiply and divide, we're multiplying 3 times 14, which is 42. That equals 4 times AB. And then you're dividing both sides by 4. And 42 divided by 4 is 10.5. Which is exactly what we got previously using the other strategy.